The effect of different variables on rideshare prices. In this project, we analyzed a dataset containing rideshare information for Uber and Lyft in Boston, Massachusetts in a given week. With the different variables in the dataset, our goal was to determine if there are any significant relationships between variables and the price of each ride. While it may seem that there are obvious factors that contribute to the pricing, we aim to see if those obvious indicators truly are influential and if there are others that might prove to be more useful. After careful analysis, we concluded that overall, distance was the only truly significant variable in determining price. While there were many other factors that might have seemed useful, like temperature and rain, these features did not yield significant improvement to our predictive model.
Our research question was, how does distance, the time of day, and climate, specifically weather and temperature, affect the prices of Uber and Lyft rides in Boston's hotspots? Additionally, how can we utilize these variables to predict the prices of Uber and Lyft rides in Boston's hotspots? We hypothesize that colder temperatures, rain, snow, and peak hours will have a positive correlation with the prices of Uber and Lyft rides in Boston's hotspots. This is because we believe that there would be a higher demand for rides under these conditions. We also predict that there would be a positive correlation between distance and the prices of Uber and Lyft rides in Boston's hotspots. We looked at the distribution for the variables that we were interested in, and almost all of them were either skewed left or right, and based on the box plot, there were many outliers. So we performed a log transformation, and the distribution became more normal with fewer outliers. We examined the relationship between the variables that we were interested in for the scatter plot, and only price and distance seemed to have a positive correlation, while others had no correlation. We then looked at the correlation matrix, and price and distance seemed to have a correlation of 0.4.
Upon first glance at the data, we believed that distance would be the biggest factor in determining price, so we looked to see if there were any clear trends between the two variables. After graphing scatter plots comparing distance and price grouped by miles, we saw that there does not seem to be any clear pattern between the two. We then started to look deeper into the relationships in our data by performing aggregate functions on key variables of interest to see any differences in groups. Overall, we found that Lyft tends to charge more for rides than Uber. Surprisingly enough, the day of the week does not seem to have any influence on price. However, the destination does. The destinations with highest average price charge were naturally places of high population density, like universities and business districts. We grouped prices by the hour but found no significant differences between the hours of the day, aside from slight increases in the early morning and before lunch. Temperature also did not show any clear trend, with prices around 1650 for all temperatures. There was a slight increase at around low 40s, but only by about 20 cents.
We're now at the point where we can try to predict the price of a cab ride using linear regression. So we can do this by taking the distance, time of day, and climate features, and we can perform multilinear or linear regression using the scikit-learn module. Next, we can use the train test split module from scikit-learn and just split the data set into 80% training and 20% testing, just so we can have a set to predict on. And now we can fit our first model using linear regression. This includes all of the variables mentioned above, multilinear regression, and our output seems to be somewhere in the $12 to $18 range. And you can see the mean squared error and metrics as well. The same thing goes for our second model, which is only using distance to predict price. And our third model as well is using time of day as a predictor to predict price. You can see all of the code here and the mean squared error and R-squared score. And finally, our last model is going to be made with the weather features as predictors. So you can see your model here and comparisons, as well as the mean squared error and the R-squared score.
So for the next part of the model, we included all the variables that were included in the past models, in addition to ordinal columns such as cab type, day of week, destination, and source as our linear regression. And with these variables, that gives us a mean squared error of 71.39 and a R-squared score of 0.17. Our conclusion indicates that distance does play a significant part in the price of Uber/Lyft rides, and that weathering information does not have any correlation whatsoever in terms of determining the price of the rides. However, after adding the ordinal variables into the linear regression, it shows that it does perform better than our previous models, indicating that there is some sort of weight that is affecting the price of the rides. However, it does not seem significant enough such that distance still has the highest weight in determining the price of the rides. One limitation to this is that the data only includes information for a week in November in 2018, so there are not many varying ranges in terms of weather. Therefore, it can affect the linear regression.